The flat edge here is the negative terminal. The longer lead is the positive terminal. Here I am inserting the 4 LEDs with the positive leads to the top. The case makes a good holder to ensure the LEDs are soldered in straight. It's a good idea to check the LED is working with a 3V coin cell before soldering it in. Just touch the lead and the pad at the same time when applying the solder. So now that I have the 4 LEDs wired in, I'm going to put two 120 ohm resistors to limit the current to the LEDs to about 20 milliamps. I ended up switching to 4 red LEDs, 2 each in series, both streams in parallel because the blue LEDs were taking too much voltage. If each LED takes 2 volts, the resistor is taking the remaining 2.4 volts divided by 120 ohms, which gives the 20 milliamps. So next I'm going to add 2 lengths of wire for the switch, but I'm not going to connect it to the switch because I've still got to attach the switch to the case. Next I need to also add 2 wires that are going to go to the battery box. Next what I need to do is to join up the resistor to the LED positive lead and join up the resistors to one of the switch cables, and then join up the negative from the battery to the negative terminal of the LEDs, and then join the negative of this LED to the positive of this LED, and same here to here. Leave a comment below if you know why I can't get the solder to flow across the adjacent pads. So I was finding it hard to get the solder to track along these pads, so I've just put some wire in between and use that to bridge the gap. Here I am joining the negative of the top LED to the positive of the bottom LED. So now that's the wire that's going to connect 2 resistors to the switch. So now I just have to jump over this wire here. That's why I've got a little bit of insulation on there. And now join that switch wire up to the second resistor. Here I am joining the switch wire to the positive battery wire. Okay, so the soldering wasn't a pretty job, but let's see if it's worked. So if I connect the two battery terminals here, and if I just connect up 6 volts to them, and then connect up the two switch wires to a switch. There we go, so now we got some lights. So next we want to attach 2 wires for the motor, and that's just got to go from anywhere on the wire between the 2 resistors and the wire down the bottom. So I'll just connect the wire from here and the wire to there. I had a problem where it didn't print out quite properly, so there's a bit of delamination there on the sides. So I've just printed out some flexible bits of plastic and I'll just glue those on just to strengthen the sides. So the battery pack I've got's got one of the 9-volt connector style connectors, so I'm just going to solder on a connector onto the 2 battery wires. So next I'm just going to pull up some heat shrink tubing over just so that these don't short out. So next I want to take the 2 switch wires and put them through the hole. So I'll put the nut on for the back of the switch. And just put them through the hole. And then I'll just solder the switch on. So I'm just using a bit of white tack to hold that down while I solder. And now I just need to attach the nut onto the back of the switch. So now I'll just give it a quick check that the LEDs are still working. Cool. So next I'm just going to use a little bit of double-sided tape to stick the circuit board in. Now I forgot to put a hole for the motor wires through, so I'll just have to drill a little hole through for those. So you can pick up cheap motors on eBay. I got this one out of an old shaver. And to connect the motor I just need to use the bracket and some M4 bolts going through the holes. I need to shorten these a little bit so they don't short on the circuit board below. So with the bracket on just like that I can just tighten these up a little bit. Now for the type of motor I've got here, these are just push fit, so you may have to solder yours. And this is the bit that you attach to the shaft, so that should just hopefully just push on. And one thing you want to do is just test the polarity. So if you just attach the wing, and when you turn it on you should just feel a bit of downdraft, a bit of wind down the way. Oops, no, where's this come out? back in. Okay, so just to go the other way around. And then the next thing is to use some more M4 bolts to attach the launcher. Just like that. So I was actually quite pleased about this bit. This bit was printed out in one part, so this has got a round rod through the middle, and it just takes a little bit of force to actually break it off. So it's actually quite neat. So the next thing to do is just to attach the battery. And just squeeze it inside the case. And just slide the base in. And just a little, I think it's an M3 screw. And I'll just attach some feet. I'm ready to give it a quick test. So it's looking good. It would be quite good if I'd worked out how to get this to come off without having to press the lever. It may just be that this isn't spinning fast enough, or need a slightly different blade design, or just somehow reduce the friction between the fan blade and the shaft adapter. So this is an idea I have to supersize the fly-in disc. So I'm going to try something out. There's some wispy bits there, so I'm just going to use a heat gun to try and remelt some of these fibres. So we'll see if this actually works. So I'm just heating this up. It's 330 degrees centigrade. Watch I don't take it too far. So it's kind of just melting the stray strands, as long as I don't keep the heat on it too long. So the idea I have here is just to take a 3-volt lithium battery, an LED and a switch, and just put that into the disc. So the first thing I want to do is put the multimeter into continuity mode, and if I just touch these, it'll tell me when I've got a straight through connection. And I just want to check which of the pins. Okay, so these outside 2 pins connect. I could just try these 2. Nothing there, and nothing with the outside. And if I switch to the other position, then it just changes. It's these 2 outside ones now that are continuity. So first thing is to push the LED all the way down. So that sticks out just a little bit on the base. The next thing I want to do is I want to take the negative terminal on the LED, and that's the shorter one, and I just want to bend that down into the battery compartment. And all that means is when I put the battery in, the negative terminal of that battery is going to be touching where the LED negative pin is. Next I'm just going to solder some wires, some short wires onto the terminals of the switch. So next I just want to put a little bit of heat shrink tubing on one of the wires, just so they don't short out. Next I want to install the switch. So to fix the switch in place, I've just put a bit of white tack down, and I'm just going to use a little bit of hot melt glue to secure these in place. So both the LED and the switch. Next I just took the black wire and the positive lead on the LED and just twisted them together, and I'll just put a bit of solder on them to secure that. So next I just squeeze these two wires together and put a bit of heat shrink on just to protect against the sharp ends. And I'll just push that down out of the way. Next I just want to trim off the end of the positive lead that's going to attach to the battery. So I just want to form a little loop there. And twist that into kind of an L shape. These are just pushing it in first and squeezing that in, and I'll just double that bit back so it's also kind of sitting on top of the battery just a little bit. So next I just want to secure the battery with some duct tape, and I'll just trim off the excess. Yep, and now I can just turn on and turn off the LED. So this was the first design I had for attaching a small blade to the top, and I found that it would chip off if I spun it up on a Dremel, chip off the supports there. So that was just to save me from printing out a larger fan. So I redesigned it to something a little bit bigger, and that'll just sit on the top like that. So what we'll have is a sanding attachment, so when you tighten up this little screw here, it pushes out on the rubber bung and just gives a friction fit. So I should be able to just tighten this up. And that won't come out. And then I can attach this to a Dremel. So let's see how it flies. I've also found if you just tilt the box like that and let it go down, then it will jump up without you having to press the lever. and occasionally it'll jump up on its own. And if you fire it at an angle, it will travel some distance as well. It's quite fun. So I'm not sure how high this thing is going to fly, if it's going to fly at all, because it's actually quite heavy, but we'll see. Oh, that thing is lethal. It's probably going up about 3 meters. I'll put links to the model files in the description below. Cheerio.